In this lesson, we are going to dive a little bit deeper into numerical models. Your warm-up journal is, forget this number 2 up there. Okay. You all make plans to hang out at a park over the weekend. Zoe lives 12 minutes away from the park. Isaac lives 24 minutes away from the park. Hawa lives 5 minutes away from the park. Nico lives 30 minutes away from the park, and Kim lives 13 minutes away from the park. I did not choose these names. Okay. Aaron lives closest to Zoe, Isaac, and Nico. How long do you predict it will take Aaron to get to the park? Explain your reasoning. Now, we're trying to figure out how long it takes Aaron to get to the park. Okay, think about this. All right? Think about it, explain your reasoning, and then put your response in your journal. So we can use information about Aaron's friends to help predict something about Aaron. It may not be 100% correct, but our prediction will probably be close enough. This is another way that computers can find patterns in data with machine learning, looking at similar data to make predictions. So in this lesson, we will explore how machines can make decisions using this same technique. Our question of the day is, how do computers make predictions with numerical data? You have an activity guide to download. The first one we're going to look at is called Zombie Prediction. All right, so we are looking at the Zombie Prediction Activity Guide. It is the first activity guide out of 2 activity guides. And I want you to look over the data. A zombie outbreak is happening across the world. The zombies are spreading in your town, but you don't know where they are grouping. Luckily, you have data from a neighboring town about where the zombies tended to gather. Using their data, can we predict how many zombies will be at locations in our town and pick the safest location to hide? All right, so look at the data. Okay, you got your data right here. Answer these questions while you're looking at the data, okay? Look over the table, then answer the questions at the bottom of the activity guide. We would share out, but we can't. We're not physically together. I don't want us to put this on the discussion board because then it might take away some of the fun, okay? You may notice that zombies tend to group at loud outdoor areas. We already know they're attracted to noise. If you've watched The Walking Dead, Fear the Walking Dead for any, half a second, you know they are attracted to loud noises. Okay, so that just seems to be proven by this data right here, right? You may also notice that zombies tend to group at locations where there are humans or animals, like schools or zoos. Duh, what else are they going to eat? Okay, you may try to justify this by making references to zombies in pop culture like I did. What other examples would help you know where to go You already know the patterns. How do you know the patterns of zombies? Okay, that you can put on the discussion board, all right? So after you've been thinking about that, we're not going to share out, okay? But if you can pull some knowledge, maybe there's a video game you played, maybe there's a different TV show, that I already mentioned, The Walking Dead and Fear the Walking Dead. I didn't really talk about zombies, though, if you're a Disney fan. Okay, go ahead and flip to the second page, creating a model. So in order to turn this data into a model that can make a prediction, we will use a technique to make similarity-based recommendations. This involves taking new data and finding similarities with the data you already have. Here is information about one location that is close to us. Location A is indoor restaurant with a low noise level and no sidewalk. Okay? How similar? You're going to be comparing the other locations on the second part of your activity guide with location A. All right, so compare location A with the features from the previous data. Anytime a column from location A matches a column for another location, that's 1 point of similarity. After comparing each column, you can add up all the points of similarity. Use the table below to keep track of how similar location A is to the other locations. The first 2 rows have already been completed. So you can see that here. Location A. You should have this on your activity guide. All right, location A. So we already know there's a similarity of 1 with location 1 and 0 with location 2. So you can put a 1 here and put a 0 here. What does location A have in common with location 1? It's indoor. What does location A have in common with location 2? Nothing. Absolutely nothing. So that's why they got a 0. You're going to keep going down this list, okay? The 3 locations most similar to location A are, don't put this on the discussion board, okay? Because it won't be as fun. Some people might try to look ahead and get the answers. To predict how many zombies could be at this location, we need to take the average of the 3 most similar locations. So, what is an average? It's where you add them all up, add all the numbers up, and then divide by however many numbers there were to begin with. So calculate the sum by adding together all the zombie values from these locations. Divide the sum by the number of values. So if I have 3 numbers, 1, 2, and 3, if I add them up, I'm going to get 6. Then I divide them by 3 because that's how many numbers I had. 6 divided by 3 is 2. Write the value in the zombies column, and that is the prediction. All right? So look at, on your activity guide, keep on scrolling down to page 3. We're going to look at B and C, location B and C. There are 2 other locations that are nearby. We need to decide whether to go hide at location A, B, or C. Use the same strategy to predict how many zombies will be at location B and at location C. Okay? So this is an example of how we can take data and compare it to our existing data, then use those similarities to make predictions. This happens a lot in machine learning apps where we are trying to predict how much something should cost, or how many people will be at a location, or how often an event will happen. But it's not enough to just make a prediction. We should also be able to check our accuracy to see how we did. So pause the video if you have not finished this activity guide, the zombies activity guide. You got to finish all the way down to the end of page 3 and let us come to a conclusion about where we should be hiding at location A, location B, or location C. Okay? The next thing, pause the video and finish that if you haven't. The next thing that we need to look at is our numerical accuracy. Okay? So, once you have finished the zombie activity guide, open the numerical accuracy activity guide. Okay, you've managed to escape the zombie outbreak and find help. You're also able to survey your town and see how many zombies were actually wandering around town. Here is the data comparing the predicted number of zombies with the actual number of zombies. Okay? Let us look. Okay? Based on the results, how many locations did the model predict exactly correct? What was the accuracy of our model? We have location A having 40, but the prediction was 25. Location B, 72, the prediction was 74. Location C, 31, the prediction was 35. What was the accuracy of this model? Our model is 0% accurate if we were expecting it to be perfectly correct. All right. Now, we should consider if it is close enough. I would say location A is not close enough. I think location B and location C are close enough, mainly because the actual number of zombies was less than the predicted number of zombies. So it's better to be lower. So for example, when the weather app predicts the temperature, because that's what's happening, it's making a prediction, we are okay if they are off by a few degrees as long as they are close. And I'm definitely okay if the actual temperature is lower than whatever it is that they predicted. Okay, you know what I'm not okay with though? If they're predicting snow and there is 0 snow, I am not okay with that. All right, don't tell me that there's going to be snow if you don't know 100% that there's going to be snow, because I don't want to get my hopes up for a snow day. All right. What would the accuracy of our model be? So let's see how we determine the accuracy, okay? Based on the results, how many locations did the model predict exactly correct? 0. 0 out of 3 correct equals 0% accuracy. What was the accuracy of our model? 0. All right. What about if the answer was within 5? A is not within 5. B is within 5 and C is within 5. So if it is within 5, 2 divided by 3 is about 60%-ish, around 60-ish%. So we're going to be completing this. If it's within 20, though, if the number is within 20 and we say all of them are correct, 3 out of 3, that would be 100% accuracy. But it's not accurate because there were a lot more zombies at location A. So if we chose to go to location A, it wouldn't work out well for us. So look at the data in the table and calculate the accuracy of our model using these 3 different approaches. exact matches, put the number correct, and then that's going to be your accuracy. So if you go back to your activity guide for numerical accuracy and then scroll down to look at this page, you're going to see exactly what you're going to be looking at. And at the bottom is where you're going to complete those 3 different types of accuracy. So like on row 1, the pizza place, there were actually 32, but the prediction was 35. Was it exact? No. Was it within 5? Yes. Within 20? Yes, technically. And so you're going to make your calculations, and then you're just going to fill in this part at the bottom whenever you get done, so we can see our accuracy within 3 different ranges. So in one of the rows, the model predicted 0, but the actual value was 2. Is this close enough to count as a correct prediction? If I'm expecting 0 zombies to be at that movie theater, but I see 2 zombies, I might be caught off guard. I might end up dead. You never know. So if you have not finished the numerical accuracy activity guide, go ahead and pause the video and finish that, and then we're going to complete our wrap-up journal. And our journal, to wrap it up, is what are other situations where you think machine learning models should be exactly accurate because close enough isn't okay? And then I also want you to answer the question of the day: how do computers make predictions with numerical data? So go to your journal and answer those, and if you have any questions, just let me know.